Maupay na aga! Good day everyone! Welcome to another science adventure where the search for the truth continues. So hang on tight for we will answer your what, why, and how questions. Let us discover the beauty of the world together, for in the great mind of a science adventurer like you, learning never stops. Let me take you to where your imagination will allow you to go. This is your science teacher Neil Brian Ambibutan, your guide in exploring and discovering the world of science tech. Come and join me in our short yet exciting science adventure. So buckle up and get ready to learn and have fun. Tara! For today's adventure, we are expected to answer the following question. First, what is the relationship between pressure and volume at a constant temperature of the gas? Second, why does increasing the volume result in a decrease in the pressure at a constant temperature of the gas? Third, how does the relationship between volume and pressure be applied in real-life setting? Reminders, please prepare your self-learning module, your paper, and your pen, for these things are vital as we continue to discover things about the relationship between volume and pressure at a constant temperature of the gas. Are you now ready? Are you now set? If you are, let's begin. Even before the idea of an atom was completed, many scientists had already investigated the reflexing concept about matter, most especially in its gaseous state, primarily because this state is considered to be the simplest. These studies resulted to what we are known as gas laws, a set of natural laws that describe the relationship of one physical parameter to another in a gaseous system. Most of these laws relate to the behavior of gases, to the conditions of temperature and pressure. In this lesson, you will be introduced to one of these gas laws, the Boyle's law. To easily understand the concept of Boyle's law, let us first unlock the following description relating to Boyle's law, which surely you have ideas with. All you need to do is to identify the term being described and write your answer on your paper. Take note that you only have 5 seconds to do it. Number 1 description. It refers to the hotness or coldness of an object. If your answer is temperature, well done! Moving on to the second description. It refers to the perpendicular force per unit area. If your answer is pressure, excellent! Moving on to the third description. It is a 3-dimensional space occupied by a substance. If your answer is volume, well, congratulations! Moving on to the fourth description. It is a state of matter that has no fixed volume and no fixed shape. If your answer is gas, very good! Moving on to our fifth description. It is the smallest particle in a chemical element or compound that has the properties of the element or compound. If your answer is molecule, terrific! Temperature, pressure, volume, gas, and molecules are some of the important terms that we have to remember thoroughly to easily understand the concept of Boyle's law. So you better take note of them. This time, we will have another adventure. Are you all excited for our next adventure? Yes, this adventure is something that we will all enjoy. Are you familiar of the game 4 Pigs 1 Word? If you do, this would be a lot easier for you. But for those who don't know yet, this is how it goes. I will be flashing out 4 pictures. What you will need to do is observe the pictures and solve the puzzle by working out what the word is or what the words are. To solve the puzzle, you will supply the missing letter below the pictures. Take note that every box corresponds to a certain letter, and you will only be given 10 seconds to solve the puzzle. Let us have number 1. If your answer is relationship, well done. Let us have number 2. If your answer is volume, you deserve 3 claps. Well done. Let us have puzzle number 3. If your answer is pressure, congratulations! Let us have puzzle number 4. If your answer is temperature, you are so good! Gases have various properties which we can observe with our senses, including gas pressure, temperature, mass, and the volume which contains the gas. Careful scientific observation has determined that these variables are related to one another, and the values of these properties determine the state of the gas. Anglo-Irish chemist Robert Boyle was able to investigate the relationship between pressure and volume of a gas using a J-shaped tube apparatus, which is closed on one end. In this experiment, he trapped air in this tube with liquid mercury. He measured the volume of the trapped air and the difference in the height of mercury columns in the 2 arms of the tube. As he poured successive amounts of mercury into the open end of the tube, he found out that the volume of the trapped air decreases. His findings show that whenever the amount of mercury is added to a J-shaped tube apparatus, a new volume and a new pressure from the trapped gas are measured. In his observation, he expressed volume readings in cubic inches and the pressure in inches of mercury. After coming up with these experiments, he then proposed Boyle's law. Boyle's law is a gas law which states that the pressure exerted by the gas is inversely proportional to the volume occupied by it. In other words, the pressure and the volume are inversely proportional for as long as the temperature and the quantity of a gas is kept constant. Trivia time! Did you know that 2 quantities are said to be inversely proportional when the value of one quantity increases with respect to a decrease in the other quantity or vice versa? This means that these 2 quantities are opposite in nature. For example, in your economics class, There is an inverse relationship between supply and prices of goods and services when demand is unchanged. This means that when the supply is high, the price is low, and if the supply is low, the price is high. Activity time! This activity is entitled Marshmallow Fluff, and the objective of this activity is to investigate the relationship between pressure and volume at a constant temperature of the gas. And for this activity, we're gonna be needing the following materials. We're gonna be needing a syringe without a needle and marshmallows. Procedure letter A. We have to put 2 marshmallows inside the syringe. Push the plunger down just until it touches the top of the marshmallow. Put your finger over the top of the syringe to form a seal. Pull up on the plunger and observe what will happen. What happens to the marshmallow? Right, the marshmallows expand. What is being decreased inside the syringe? As I pull up the syringe, the pressure inside it decreases. What is being increased? Right, since the pressure inside the syringe decreases, the volume increases. And that makes the marshmallows expand. Procedure B. Take your finger off the tip. Pull the plunger to the top of the syringe. Seal the tip with your finger again and push the plunger down and observe what will happen. Question: what happened to the marshmallow? The marshmallow shrink. This time, what is being decreased inside the syringe? As we push the plunger down, the volume of the syringe decreases. And what is being increased? As we push the plunger down, the pressure inside the syringe increases. Explain why was it so? This is because volume and pressure are inversely related. As the volume increases, the pressure decreases. And as the volume decreases, the pressure increases. Therefore, we can conclude that when the syringe plunger is pulled out, the volume of the chamber increases, but the amount of gas remains constant because it is in a closed system. The pressure inside the syringe chamber decreases. The lower pressure on the marshmallow causes its volume to increase according to Boyle's law. The expansion is due to the many trapped air bubbles within the marshmallow that initially are at atmospheric pressure. As the pressure outside these air bubbles is reduced, the bubbles will expand to many times the original volume in order to equilibrate the pressure on either side of the bubble wall. Thus, as the pressure decreases, volume increases in an inverse relationship. Activity time!
Direction. Identify which of the following describes Boyle's law. Put a check if it does. Put a cross if it does not. Number 1. breathing process.
In grade 9, your teacher probably asked you to make a long model to explain respiratory system. What do you notice as you pull the bigger balloon that represents the diaphragm? Yes, the lungs expand. This actually applies Boyle's law. Pulling the rubber balloon represents inhaling. As you inhale, the lung cavity expands, causing the pressure inside the lungs to decrease and become lower than the outside pressure. As a result, air flows from the higher pressure area, which is outside the body, into the lungs. Exhaling is the opposite process. When you release the rubber, which represents the diaphragm, the balloon representing the lungs decreases in volume. When the diaphragm contracts as you exhale, it results to a decrease in the lung volume, increasing the pressure inside the chest cavity and causing the air to flow outside of the lungs.
Number 2. Dented ping pong ball. Number 3. Heating aerosol. Number 4. Pressure cooker. Number 5. Scuba diving. Number 6. Baking bread. Number 7. Puffed up chip bag.
When we go to higher altitude, the pressure lessens. So when the air pressure outside the bag of chips is lesser than the inside, the air in the bag of chips expand, causing the bag to inflate and to some extent explode.
Number 8. Placing a balloon in a liquid nitrogen. Number 9. Hot air balloon. Number 10. Working on a syringe.
Let us have first a stretching activity for you to be able to answer better. For our stretching activity, we'll have 4 figures. Figure 1, head rotation. Figure 2, shoulder rotation. Figure 3, hip rotation. And figure 4, jog in place. Are you now ready? I know you're ready. Let's do this. In the count of 3. 1, 2, 1, 2, 3. stretching activity? I hope so. Now let's dive into our activity.
Direction. Read each item carefully and write the letter that corresponds to your answer in your answer sheet. Question number 1. When pressure increases, volume will A. Increase, B. Stays the same, C. Decrease, or letter D. No effect. Number 2. What is held constant in Boyle's law? Is it letter A. Temperature, letter B. Pressure, letter C. Volume, or is it letter D. Number of moles? Question number 3. Who was the physicist discover inverse relationship of pressure and volume at constant temperature of a gas? A. Robert Einstein, B. Robert Boyle, C. Robert Park, or letter D. Robert Darwin? Question number 4. At constant temperature, what happens to the pressure when the volume is doubled? A. It is halved, B. It is doubled, C. It remains the same, or letter D. It is quadrupled. Question number 5. At constant temperature, what happens to the volume when the pressure is tripled? Is it letter A. It decreased 1/3, letter B. It remains the same, letter C. It is halved, or letter D. None of the above? Question number 6. What is the relationship between pressure and volume at constant temperature of the gas called? A. Inversely proportional, B. No relationship at all, C. Directly proportional, or letter D. None of the above? Question number 7. The relationship of which two variables are compared in Boyle's law? A. Pressure and volume, B. Volume and temperature, C. Pressure and temperature, or D. Volume and number of moles? Question number 8. Sir Brian decides to go to scuba diving while on vacation in Palawan. As he swims deeper into the ocean, the pressure pushes on him increases. Based on the relationship in Boyle's law, what would happen to the volume of Sir Brian's lungs with this increase in pressure? A. Volume of the lungs will increase, B. Volume of the lungs would have no change, C. Volume of the lungs will decrease, or letter D. Volume of the lungs would double? Question number 9. Each container with varying volume has 1.0 mole of oxygen gas at 30 degrees Celsius. In which container will pressure be the lowest? Is it letter A. 1 liter, B. 5 liters, C. 9 liters, or letter D. 12 liters? Question number 10. How do gas particles respond to an increase in the volume? A. Increase in kinetic energy and decrease in temperature, B. Decrease in kinetic energy and decrease in pressure, letter C. Increase in temperature and increase in pressure, letter D. Increase in kinetic energy and increase in temperature.